Today we're going to be learning how to solve systems using a different method called the substitution method. The steps to solve the systems using substitution are: step 1. Solve one of the equations for either x or y. One of the two equations has to have a variable isolated in order for substitution to work. Step 2. Substitute the expression for the variable into the other equation. That's important that it's the other equation. Then you'll have one equation with only one variable. So step 3 would be solve that equation. Step 4, substitute your answer from step 3 into one of the original equations to solve for this second variable. And then step 5, solve and write your answer as an ordered pair. Now that may seem like a lot of steps to you, but it's not so bad once you see it worked out. So step 1. Solve one equation for either x or y. Now this actually already happens to have a y equals on my equation, so step 1 is basically already done. Check. Step 2, substitute that expression. So I'm taking this expression 2x minus 1 and substituting it into the variable in the other equation. So it's going into the other equation. So what I'm going to do is I'm going to write x plus y equals 11. But I'm going to come in and erase y. The reason I'm going to come and erase y, okay, so x plus blank equals 11, is because I know what y is equal to because of my purple equation. My purple equation says y is equal to 2x minus 1. So wherever the y was, I erase the y and replace that with 2x minus 1. So I'm substituting the y in the first equation with whatever y is equal to in the second equation. That's why we call it substitution. Now look, we only have one equation with one variable, so I can go ahead and solve that one equation. So that leaves me with x plus 2x, that's 3x's. I'm going to add 1 to both sides. 3x equals 12, and then divide both sides by 3. So that gives me y is equal to 4. So my answer is the x equals 4. That's not my entire answer, but that's the x coordinate of my ordered pair. How am I going to figure out what the y coordinate is? Well, step 4 says substitute your answer from step 3. So I've already done step 3 to solve it. So I'm going to take this answer and I'm going to substitute it in to one of the top two equations. It doesn't really matter which equation you pick. I am going to pick the second equation because it's already solved for y, and I like that. So we have y equals 2x minus 1. But instead of the x, I'm going to come in and erase the x and replace x with the 4 that I know x is equal to. So I have y is equal to 2 times 4 is 8, and 8 minus 1 is 7. So my answer is 4, 7. If I would have graphed these two, then these two equations would intersect at 4, 7. But I'm not sure about you, but graphing seems kind of frustrating to me because you have to do a lot of work just to get the equation. But this way, I can do it all in algebra, get my equations, especially if the numbers are really, really big. And this is where they would have intersected had they been graphed. Now, if I really want, I could check my work. This is not required, but I'm going to show you how to do it. So I'm going to use the first equation, x plus y equals 11. My x is 4 plus y is 7. Does that equal 11? Yes, it does. Now I'm going to plug it in the second one. Y equals, my y is 7, so 7 equals 2 times 4 minus 1. 2 times 4 is 8, 8 minus 1 is 7, so they both check out. So this solution satisfies both equations, and there's only one point in the whole world that'll satisfy both equations, because if I graphed them they would intersect and you could see that there's only one solution. Let's try this again. On this equation we have x already by itself. So step 1, solve one equation for either x or y. Check, step 1 is already done. So I'm going to take what this is equal to and plug it into the other equation. Now my other equation says 2x minus 3y equals 17. But instead of x, I'm going to come in and erase that x. And what can I put instead of x? Well, inside parentheses, because I'm taking 2 times the whole thing, so I need to use parentheses, negative y plus 6. 2 times what the x is equal to, minus 3y equals 17. So now I can solve this equation. Notice this equation only has y's in it. When you have 2 equations with 2 letters in it, it's too hard. But when you use substitution, now all I have is 1 equation with 1 letter, and that is totally something we've already done before. I know how to solve 1 equation with 1 letter. Because the y's are on the same side, I'm just going to add them. If you need to use a calculator, you can. Negative 2 minus 3 is negative 5y. Now, to get y all by itself, I'm going to subtract 12 on both sides. Negative 5y equals, that's positive 5. And then I divide both sides by negative 5, which gets me y is equal to negative 1. So in my answer, I have one of the ordered pairs. This time I have the y, so it's going to actually go in the back, not the front. A lot of students mistakenly think that the first answer always goes in the front. Not so. This time I got y first, so it goes in the back. Now I'm going to plug this into the either equation that I like. I prefer the second one because the second one's already solved for x. I'm going to come in and erase my y and replace that erase mark with a parentheses. And inside that parentheses, I'm going to put a negative 1. So I have x equals negative because there's a negative in the formula, and a negative 1 because there's a negative 1 on the y, plus 6. Negative times a negative is actually a positive 1 plus 6, which is 7. If I want to check, which you don't have to, I could take 2 times x, which is 7, minus 3 times y, which is negative 1, and see if that equals 17. Let's see, that's 14 plus 3. Yep, does equal 17. That's correct. And then I would check the other one, x, which is 7, equals negative 1 plus 6, and that's also true. Negative 1 is 1, and 1 plus 6 is 7. So both of these check out, and that tells me that I did my problem correct. Our next problem is the first time that step 1 isn't already done for us. Step 1 says solve one equation for either x or y. Now, it doesn't really matter which equation that you use and which one you solve for x or y. It doesn't really matter. But I would identify this x, or this y because they don't have any coefficients. Those are the ones that I would probably solve for. It doesn't really matter. Let's pick x on the first one, okay? So what I'm going to do is I'm going to rewrite this equation as x equals, who needs to get moved to the other side? Well, it's the y that needs to get moved. Now that's a negative y because the negative always gets assigned to the guy behind him. So the negative y moves to the other side and becomes positive y. So this is my new equation. I'm going to take this and plug it into the other equation, which says x plus 2y equals negative 1. Instead of that x, I'm not going to write x. What can I write instead of x? Well, what x is equal to, which is y plus 5. Now I only have one equation with one variable. So now we're on to step 3, which is solve that one equation with one variable. So y plus 2y on the same side, that's 3y's. Just combining like terms there. To get the 5 on this side with the numbers, I'm going to subtract 5 on both sides. That gets me 3y equals negative 6. And then divide both sides by 3. Y is equal to negative 2. So in my answer, the y is 2, negative 2. So how am I going to find the x? I'm going to go ahead and plug it back in to any of the original problems. Now, I'm going to choose the x equals, because it's already solved for x. X equals y plus 5, but instead of y, I'm going to replace y with negative 2, because I already know that y is equal to negative 2. To solve this, that's pretty simple. Negative 2 plus 5 is 3. And that's my solution. If you want to check, you could by taking 3. Anytime you see an x, plug it in to 3. So 3 minus a negative 2, does that equal 5? Yep, 3 plus 2 is 5, because minus a negative is add a positive. And then 3 plus 2 times y, which is negative 2, does that equal negative 1? 3 minus 4 is negative 1, so it works. You don't have to show me your check. This is just purely optional if you want to make sure that you're doing it right.